All right, well, today we get into 1.2, Investigation 1.2, and really concentrating on how we can maneuver equations. We did this in a little bit at the end of 1.1, but how we can maneuver equations from standard form into slope-intercept form and vice versa. So that is going to be our focus for today. So really quick, what I want you guys to do is on page 10, it says, read the opening paragraph and take notes about the different forms of linear equations, all right? Also known as linear functions. So I just want you to, we're going to pause this video. I want you just to take a few minutes and just kind of take a peek, read over it real quick and just get a good understanding for what we're talking about here. And put some notes in the slope-intercept form box and standard form box, and you can kind of add what I put in. All right, so go ahead and pause this right now, and then we'll come right back to it. All right, well, in slope-intercept form, obviously the main idea, obviously for slope-intercept form is y equals mx plus b. And obviously in standard form, it's a different equation, ax plus by equals c. So those are the two forms between standard form and slope-intercept form. In slope-intercept form, okay, one variable, which is y, depends upon the other variable. Which that's x. Independent, dependent variable. In standard form, the scenarios you tend to get are two variables combine to produce a fixed third quantity. And that fixed third quantity is your C. Okay. Also, one more important thing here, A, B, and C, which are integers. Okay. They cannot be fractions or decimals. So they have to be in integer form, positive or negative. Okay. So that's kind of what you took away from page 10. All right. Now explain why b in the form of yx and from y equals mx plus b, and the b from ax plus by are not the same thing, even though they appear to be the same letter. Well, a and b, in terms of just the numbers that they can be integers, but b can also be fractions, can be decimals, can be from the y equals mx plus b. But their meanings are different. All right, and the b in y equals mx plus b signifies the y-intercept. And remember, the y-intercept can be a whole number, it can be an integer, it can be a fraction, it can be a decimal, it can be lots of things. The b in ax plus by equals c can only be an integer. It has no meaning in terms of the graph or anything like that. It just basically signifies some kind of integer that the variable could be in a certain story. It has no y-intercept meaning or slope or anything like that. So they're two different meanings. Obviously, are significantly different. All right. So now here you're coming upon our first task. Okay, the bottom of your page. It says 4 students tried to write 12x plus 3y equals 9 in equivalent y equals mx plus b form. Did each student get an equation equivalent to the original ax plus by equals c form? If so, Explain the reasoning for each step. If not, tell what the errors the student made. So we're going to give you guys some time here to work on this as a team. All right, Jared, Molly, Mia, and Allie all try to do these, take the same problem and put it into slope-intercept form. Okay. We'll give you a hint here. Two did it correctly and two did it incorrectly. As you can see, two answers are the same. We got a couple different answers here, so let's see what you guys can do here. We'll pause the video and play it once everyone has had a chance to answer it. So go ahead and pause the video right now. Okay. Well, we look at Jared first. Okay. Well, the first one here. Okay, we got 12x plus 3y equals 9. Well, in this first step, you notice how there's nothing on this. The only thing by itself is the 3y, and the other side is the minus 12x. So what he did is he subtracted 12x to each side, which is correct, right? And then if you notice from when he goes from step 1 to step 2, he goes to y equals negative 4x plus 3, which all he did is he divided both sides by 3. So Jared is correct. Okay. Now if you notice, Mia has the same answer. So if Jared's correct, she's correct, but she did it a little bit different, didn't she? If you look at her first step, what did she do? She divided everything by 3 first. Okay. She divided everything by 3 first. All right. So the second step, you noticed she took the 4x and moved it over, right? Subtracted. So she subtracted 4x to both sides. All right. In the last step, all she did was switched the negative 4x into 3 to put in y equals mx plus b. She just changed the order. So basically, she just used the commutative property, which is perfectly fine because the signs go with the right numbers. Okay. Notice how the minus 4x is here, and now it's out in front. So she did the right way. She just didn't move the numbers. She made sure the signs moved with the right numbers, and that's important. All right. So if we know that Mia and Jared are correct, we know that these two guys are wrong. But let's see if we can prove what they did wrong. So if we look at Molly first, all right, Molly started off by moving the 12x. So she subtracted 12x to each side, which is fine. Now, if you look at her next step, she goes from 3y equals 9 minus 12x to y equals 3 minus 12x. So here is her error. She divided everything by 3, except she didn't divide the negative 12x by 3. So this technically should be minus 4x. So that's where she made her mistake. You got to divide every term when you divide through. Okay? Not just one. And that's the mistake she made, is she just divided one. All right? So Allie, down here, kind of starts off the same way Molly did. She subtracted 12x from both sides. Okay. And if you look, her step 2 is fine because she divides both sides by 3. And she divides every single term. But what she screwed up on is she failed to use the commutative property the right way. When she moves the 4x, it should be a minus 4x out in front. And she didn't use that. So she used the commutative property incorrectly. Okay. So big mistake there. Okay, so you can see the differences there. Making one little simple mistake can really, really throw you off. So You gotta be careful. All right, so moving on to the back page. Okay. Your next goal is we're going to practice changing things from standard form into slope-intercept form. So you had some examples on the previous page with Jared, Molly, Allie, and Mia. So you want to use the good examples and not the two bad ones. So we're going to give you guys again a little bit of time to try this out, and then we'll come together and do it. I'll model it afterwards. So I want you again to pause the video and try to take these two equations into slope-intercept form. All right, go ahead and pause the video. All right. Again, when you get things in a slope-intercept form, you want to isolate the y. Okay. So when you get y equals mx plus b, all right, the first thing I got to move is I got to get the x on the opposite side. So I want to take this 8x and move it. So the only way I can do that is subtracting 8x to both sides. All right, so when I do that, I'm left with minus 4y. Don't forget your sign. And I get minus 8x plus 4. And I'm going to try to keep it in slope-intercept form. I always want to keep my x in front just to make life easier on me. So now I got to get y all by itself. So to get y all by itself, I got to divide every single term by negative 4. Okay? Every single term. So negative 4 over negative 4 becomes 1, leaving me just y, and that's our goal here. Negative 8 over negative 4 is positive 2. That leaves me 2x. And 4 divided by negative 4 is negative 1. So now our y-intercept becomes minus 1 here. And again, what can I see by looking at this equation? I can see our slope of this graph. And remember, this and this is the same line. These are equivalent equations. Okay? They're in different forms. Okay? And then I got my negative 1 as my y-intercept. So again, I can see that when it's in slope-intercept form. I can't see that when it's up here in standard form. It makes life very difficult for me. Okay? All right. Number 2. Again, I want to need the x and the y on opposite sides, so I'm going to move the x over. By doing that, I'm left with 5y equals negative x minus 30. Okay, so now I got to get y by itself. I'm going to divide everything here by 5. So 5 divided by 5 is 1, leaving me just the y. Now, you can write it like this. Negative x over 5. Just know that that's negative 1/5. So you could also write it like this. Negative 1/5 x, same thing. And then negative 30 over 5 is negative 6. Okay. So again, both of these are fine, however you want to write it. They mean the same thing. Okay. So again, this equation and this equation are the same. All right. They're just in different forms. Okay. So that's taking things from standard form into slope-intercept form. You got to split the x's and y's on opposite sides of the equal sign, and then isolate the y. Okay, almost like solving an equation, except we're just solving it for y instead of actually getting y by itself. All right. All right. Let's move on. So now going back the other way. So when I change an equation into standard form, so meaning we go from y equals mx plus b to standard form, we're just working backwards. So the standard protocol is the coefficient in front of x, which is a is always the number in front of x, right? ax plus by equals c. Must be a whole number. Okay, that means your first digit has to be positive. A whole number is basically 1, 2, 3, 4, 5, so on. Okay? No fractions. No decimals. Okay. That's important. So that first number has to be positive. Can't be anything different. So as we go through a couple scenarios here, we're going to do the first two together. And then this should give you some an opportunity going forward to work on it and see how you do. So now when I go to standard form, I have to put both variables on the same side. So you notice I got a y here and an x over here. So I got to get this x over to here. So again, to move that across the equal sign, I have to do the opposite, which means I have to add 3x to both sides. Okay. When I do that, I'm left with 3x plus y equals 5. So do I ask myself, is the coefficient in front of the x a whole number? Is 3 a whole number? Yes, it is. Are there any fractions or decimals in my answer? No, there is not. So this is actually the answer in standard form. And again, remember, this form and this form are equivalent equations. They're just in different forms. Okay? If you were to graph them, they're the exact same line. All right, now number 2 is a little more tricky because we have a fraction in here. And we'll show you how to get rid of that. So again, I have x's and y's on opposite sides. So I got to take this 3/4 x and move it over to here. So I got to do that by subtracting 3/4 x to both sides. Okay. So when I do that, I get negative 3/4 x plus y equals 1. So now again, do I ask myself, well, this is violating 2 rules, right? The number in front of x is not a whole number. It's negative and it's a fraction. It's a double whammy. So to get rid of a fraction, if I multiply both sides of the equation by the denominator, I can get rid of this. So I'm going to take this whole expression, negative 3/4 x plus y, okay, and I'm going to multiply it by 4. And then whatever I do to the left side, I have to do the right side. So if I distribute a 4 in, okay, 4 times negative 3/4 x is negative 3x. All right, because the 4's cancel out. Because basically what you're doing here is taking 4 over 1 times 1/4, or 3/4, right? They cancel. Okay. And then 4 times y is 4y, and this is 4. Okay. So now we got rid of the fractions, right? All right. But we're still violating one rule, and that's the first one. The coefficient in front of x, this number, must be a whole number. Is negative 3 a whole number? No, it is not. So to make this positive, I'm going to multiply both sides again, but I'm going to multiply it by negative 1. Because it doesn't change the numbers, it just changes the signs. So negative 1 times negative 3x is 3x. Negative 1 times 4y is negative 4y. And this becomes negative 4. And this becomes our answer in standard form, because now that first number is a whole number. Now, you could have saved yourself an extra step by, if you would, when I multiplied by 4, I could have multiplied by negative 4. Okay? And basically, that would have left us with negative 3 over negative 1, which is a positive. But I wanted to kind of go the long way just to kind of show you how to do it. So now that you got 2 examples here, I want you to take your time and I want you to work on the 3 and 4. So we're going to pause this video again, and I want you to try to work on 3 and 4 and see what you come up with. All right, go ahead and pause it. Okay, well, now that you've had an opportunity to work on those, let's see how you did. Well, again, with the number 3, I got x and y on the opposite sides. So they got to come over together. So I'm going to move the y over, because that'll leave the c by itself. So when I move the y over, it's got to be minus 2y to both sides, right? And that leaves me x minus 2y equals negative 3. So now I got to ask myself, again, these rules. To change it into standard form, did I hit these 3 things? The coefficient in front of x, is it a whole number? Well, what's in front of the x here? 1, correct. Is 1 a whole number? Yes, it is. So we are good to go there. Are there any fractions here? Nope. Are there any decimals here? Nope. And b and c are still integers, so guess what? We only had to do 1 step to get that. That was kind of nice. That was a lot like number 1. 1 step, we got the answer. Now, the last one, we got some work to do here. Because if I go ahead and multiply both sides by a number, I got denominators, or I got fractions in both x's and y's. but my denominator isn't the same. It's a 5 and a 3. Okay? So what I got to do is kind of find a common multiple between 5 and 3. So when I multiply, I get rid of both fractions. Okay? If I just multiply 1 through by 5, I'm only getting rid of 1 and not the other. So who can think of what is a common multiple between 3 and 5? Multiple. Not a least common denominator or anything like that. Multiple. Think of 5, 10, 15, 20, 25, and so on, and then 3s. You're right, 15. All right? So if I take this whole expression here and multiply it by 15, and I take this whole expression and multiply it by 15. So we're just going to straight multiply it up. I'm not going to worry about cross-producting or any of that stuff. But if I go ahead and distribute this, so 15 times 2/5 is 30/5. And 15 times 5 is 75, so that's 75/3. And then over here, 4 times 15 is 60. So now we're going to see if these improper fractions here and here should hopefully now become whole numbers. So if you take 30 divided by 5, that's 6. And if you take 75 and divide it by 3, that's 25. And now that leaves us 60. So again, we have no fractions or decimals. There's a coefficient in front of the x, a whole number. That's 6. 6 is a whole number. Here is our standard form. All right. So the last part of this lesson is going to deal with writing an equation in slope-intercept or standard form to model each situation. Explain why you chose those forms. Let's zip on over here. So we got to think of it. They're talking about one variable. Is one variable dependent upon the other? Or are two variables, like we said in the beginning, are two variables combined to produce a fixed third quantity? So you look at number 1, it says Mary's selling popcorn for $5 per bucket and hot dogs for $4.75 each. After 1 hour, she makes $72.50. So here, this is going to be one that we're going to talk about in standard form, okay? Because we got two variables here, the popcorn and the hot dogs are going to combine to make that much money. So if our popcorn is $5 per bucket, and that's also added to the because the word and, the hot dogs are $4.75, and you get $72.50. Now I know we say usually in standard form, you can't leave it. That's only when we're converting. If we're writing an equation, this is dealing with money. We need these decimals because it's dealing with money. Here is our equation that we would need for this scenario. So again, what I want you to do for the last time is you're going to pause this video, and I want you to see if you can come up with two equations for 2 and 3, and then we'll come together and see how you did. So go ahead and pause the video one last time. All right. So number 2, it says Matt is in charge of selling roses for the Valentine's Day dance. The roses sell for $3.75 each. He estimates that his expenses for the roses are $25. Matt wants to write an equation for the profit. So if we're talking about a profit equation, we talked about this in Say It With Symbols. A profit equation is actually slope-intercept form, right? So we're going to call this slope-intercept form, right? So if we have y being our profit, okay, instead of p, and number, it's income, and we're trying to model it to this, right? But instead now, our P will be our Y and our I will be our X. Well, if he makes $3.75, he's selling them for $3.75, right? That's his income. So 375X, and then it minus his expenses. Well, they said his combined expenses are just $25. So minus 25, there is your equation for number 2. And it models the profit equation, which we talked about in Say It With Symbols. All right, last but not least, it says Kaylee is mixing paint for an art project. She mixes 5 ounces of green paint with every 3 ounces of white paint. She needs 50 ounces of the paint mixture, whatever color that's going to make. So again, here we're talking about two variables that combine to make a third fixed variable. So this would be standard form. So since green is first, we'll make green the x. So she's 5 ounces of the green with the 3 ounces of the white, and she's going to get that how many ounces total. So again, that's how you can come up with these equations in standard form or slope-intercept form for this. So here is the homework assignment for this section, page 14 and 15, 9 to 17, and page 17, 39 to 40. So I hope you found this lesson helpful.